professional learning. Our experts, facilitators, amazing Rebecca, amazing Zach, Setigan, Sola, are training us to be leaders. Leaders in our classes, this is instructional leadership. Leaders in our association, this is association leadership, and in our communities. Leaders in our departments, and this is policy leadership. Our power is essentially our proficiency and skill in our classes. That's why our trainers emphasize the build of lesson plan capabilities and how to implement it effectively. And that's very, very important. I was amazingly surprised by the fact that we are committed to conceive a professional plan. As a leader, PhET trainers ask me, do you want to change the course of events? Then build the plan and implement it during your professional leadership. And the plan it is. Let's see together and extract meaningful knowledge from PhET approaches in general. When our trainers implement the planned structure of the teacher leadership framework during our professional learning, they act as facilitator according to well-defined foundations. They train us to be usually reflective, to communicate well and respectively, to be aware of our professional, personal effectiveness and interpersonal effectiveness, and many fruitful values. Also, that's the two external envelopes. Inside, protected by those foundations, there is the three pathways, the three leadership for teacher leadership and their competences. As for any professional plan, a timeline is a necessity with the most important activities during our pathways through leadership learning. I was attracted by a statement related to policy leadership. STEM teachers know how to shift from problem-focused thinking to solution-focused thinking. We need that. Among those pathways, PhET provides us with indicators that show us rationally how far we demonstrate each leadership, either at emerging level or deeper at transformed level. PhET has its research-based ways of doing. As we see here, PhET trainers act with clear consistency of those approaches. We usually see among group activities that trainers ensure governance. Every step is already planned. We know where we are going. And also, we feel structure everywhere, and they always maintain momentum to show us persistence that we need the most. Also, to show us that persistence has its social impact and to keep us motivated. They show us that direct impact slowly increase, but at certain tipping point, there is an exponentially increase of the indirect impact. Leadership plan, indeed. As consistent as they are, our trainers request from us the pillars of our strategic plan. I mean by that, vision, mission, values, goals, they add purpose, and they ask for logic reasons for our choices. We are always trained on discussion, on giving rationale, on giving evidence. So we have to diagnose our elementary educational system, our classes, our establishment, and identify problems. They told us that problems are transformable to opportunities. They imply here to strategic plan approach where we seek strengths, weaknesses, opportunities, and threats. what we call SWOT. Also, we define goals. We have to determine our goals as solution to detected problems and provide a rationale for that association. We have to identify our needs, our inputs, what we have to fix what we will give as outputs, as activities, and we have to identify impacts. The impacts should be measured by our own indicators. A narrative document explaining all this work in details is needed and will be provided within our final portfolio. As I said previously, our strength is our teaching skill, and PhET themes are now a powerful proxy for active learning. So, what methodology PhET implement to reach active learning in classes? 3 levels are illustrated. We have to choose first the PhET simulation, adapted one according to knowledge content. Lesson plan, our lesson, then the lesson plan is designed according to active learning approach. Finally, within implementation levels, teacher facilitate the process according to certain behavioral strategies. Not only the plan should be designed, but how it will be implemented is very important, and it has its strategies. We will see that on examples. Here, a spectrum of active learning. And the beauty of this picture is in its classification. I mean by that, we see on the left side teaching methodologies based on lecture with more control to teacher. And PhET considers that it has a membership in a spectrum of active learning. How can we transfer cold lectures into active learning? It can be done. How? By whole class strategy. Whole class strategies. Those strategies will be distributed from the most left side to the middle of the spectrum, according to its rate of interactivity with the students. First whole class strategy is whole class inquiry, which is considered the least active strategy. But the magic word, inquiry, will displace it far away from traditional lecture environment. Then we have the second whole class strategy is interactive lecture demonstration, which is more active than the precedent one. Do you hear this paradoxal nomination? Interactive lecture. Indeed it is. We will see the harmony inside. The last whole class strategy is called concept questions, which ensure the most active learning approach with the whole class together. We will see different design for those questions. Then we finish by the right side of the spectrum with individual or small group. We will deal with this group activities. Students will enjoy with motivational activities autonomously. That's why we have to design carefully an activity sheet that realize that enjoyment. All those strategies are designed with lesson plan that are quite similar. In order to make learning active, the lesson is planned according to PhET methodology with 7 important and rational steps. First one, we have to understand the students' prior knowledge, because that leads to what we call cognitive dissonance or cognitive conflict. It happens when the students find himself incapable of providing evidence on what he sees, what he manipulates, what he discovers. So, and that at that important moment, he will try to adapt with new knowledge. Then all our content should be connected to everyday life. This will give meaning to our learning, and this will motivate our learners. We have to support collaboration. It is one of the most strong point in all PhET strategies and methodologies. Collaboration, discussion, initiative. So we have to support collaboration. We have to engage our students to explain, to discuss, to defend their opinion, etc. Our students have the right to make mistakes. I rather said we have to celebrate mistakes. So we have to make our environment secure, safe. Scaffolding is very important. It allows the progress at everyone progress at his own pace, make sense of information, formalize ideas, same level for understanding. We have to check for that. Then assessment and formative one. Formative assessment is very important. It has to give to students the feeling of achievement when he is assessed and he's convinced that he answered right, he is on the right way, he achieved. Then the learning side, which is the new class dynamics with these approaches. This lesson plan is facilitated on field according to strategy. That's what we call the strategy of implementing. When we have our plan, how do we implement? How we behave as teachers to implement that? And PhET give us a very fruitful and instructive videos where teachers speak, describe. One of the teachers said that I never touch the keyboard of my students. Even they are not reaching the goal, I have other methods to imply to give him back to the right path. Let's proceed. So the strategies is open play. First of all, the students have the freedom to play with the simulation. We have as teacher to circulate in the classroom. We are here. We encourage and solicit student ideas. We help them. We check on understanding. We facilitate discussion. This is very important. Discussion between peers, and also whole class discussion. We summarize all ideas, all initiatives, and we are always flexible. Even when we don't find what we are waiting for, we can, with our tools, with our behaviors, with our question, make them back. Let's proceed to the implementation strategy of whole class inquiry. So in this whole class session, students are given time to inquire and predict answer. Then to discuss their prediction with their peers. We have the prediction part, first of all, when the teacher asks question, place his students in some situation, students predicts, discuss their peers, then they observe demonstration. The discussion is important because this can allow them to confirm or disprove their predictions. And then when they observe demonstration, they will reflect and discuss on what they found. Let's treat an example. Here, the objective of our session here, the student will be able to identify the longitudinal wave or transversal wave. In the wave study, there is two types of waves, longitudinal one, transversal one. So here, what happened to the particle movement if we spill consecutively drops of water? This is the question, the situation, the question that I will begin with my students. I will ask them to identify this kind of waves when it progresses in water. Let's see the example. We have the simulation here, waves with water, and I make my students see this propagation of wave. My students already know what is wave, its definition. It is a traveling disturbance in a medium that carries energy. So here, I put them in the problem, identify this wave. They think about identifying the direction of movement, the movement of particles and the propagation of wave. So they can see this side view, ask me to put the side view, and here with reflection, with discussion, maybe they can put what they see in their student sheet, activity sheet, as we will see. Also, for the sound, propagation of sound. And here, and I ask them, you see the wave propagation, which kind of wave is that? As they saw with water, they will ask me the side view. The side view is similar. The waves are spheric. So our students are very intelligent. They are very, they can manipulate those simulations. For sure, they will notice this and they will ask for particles. And here, they will see the movement of the particles. Here, the movement of the propagation of wave, even both. And they can identify relatively the movement of particles comparing to the propagation of wave. Going back to our presentation here. So what on their sheet, they will add that double arrow, the movement of particles, the propagation of wave. So we see here, this is the first kind of wave that we call transversal. Second one, they identify the movement of particle, the propagation of wave, and this is longitudinal wave. So this is done with the first methodology strategy of whole class learning. We can use what we call what we saw the formative assessment. Now I can ask them to use this simulation to show me what kind of wave is this. Let's see what possible manipulation, what possible suggestions they can give. So here I show them an oscillation of no end, no damping, and here I ask, what is the kind of this wave? Longitudinal or transversal, and why? And why? I can facilitate the task by giving slow motion, but here I'm waiting for a suggestion to manipulate experimental tools to identify movement. I mean by that, I'm waiting for my students to tell me we should use rulers. If I have no such command, I will click without saying anything. So here the rulers, I will stop the animation, put the rulers on one particle, the green one, and run it. And it is clear now that the particles are in vertical movement, the wave are in horizontal movement, perpendicular. So this is a transversal wave. Okay. Then, after the first whole class inquiry strategy, we are still in whole class strategies. We move to more activity and more interaction in learning, the interactive lecture demonstration. A sheet called prediction sheet will be distributed at the beginning of this session with these strategies. So after introducing the simulation, students on their sheets will answer the question, will describe the situation given by the teachers on their prediction sheet. Then they will discuss it in small groups, then in whole class discussion, all animated by the teacher. After that, they will observe demonstration. They will have the result of their prediction, and they will reflect and discuss. Back to this discussion, they fill their prediction sheet to explain discrepancies, and then they consolidate what they learned within final conclusion. Let's see with an example, concrete example. If we have to achieve this objective, the student will be able to determine the characteristics of the interaction forces between two electric charges. I'm speaking about Coulomb law. So here, as usual, there is a prediction sheet. Coulomb's law, we began by the first objective. We provide pictures that illustrate 3 different cases, maybe more, and we ask the what if question. What happens if we place 2 electric charges in front of each other? So here, the manipulation that can be done is to have 2 solids, charged solids, and we will vary the charge. Here, I am waiting for my students to suggest to me what variable I will vary. I will lead them to suggest one positive charge, another negative charge. They will see the attraction. Then when 2 charges are negative, repulsion. When the 2 charges are positive, same repulsion. And also, they will be lead to suggest to vary distance. And we see here, when we vary one distance, when we move one solid, the distance between both of them increase or decrease. When the distance decrease, both 2 forces increase. Also, when I vary one charge, only one, 2 forces varies. And when charge increase, force increase. So here, students step by step can construct the relationship between the interaction, electric force, and those variables. Okay, we come back to our presentation. Then, after the interactive lecture demonstration, concept question now. Let's see example for concept question. Let's see before that the strategy. Concept questions is based on challenging questions that are given by the teacher at the beginning of the session. Then a discuss with peers will be done. Then a vote. Here, the particularity of this methodology. All students will vote to choose the right answer. Then we will have a whole class discussion. We will discuss the results. At this moment, we observe demonstration and we reflect and discuss also to understand why we were wrong or why we were right. Let's see an example. Let's speak about nuclear disintegration. The student will be able to define alpha decay as nuclear disintegration type. The student here know already that alpha decay is the emission of helium nucleus, but he didn't know how the process is done. So here the multiple choice concept question. The first type is interpreting and representing. Interpreting, we give him a picture and he tried to interpret. So here's the question. Alpha decay is a nuclear disintegration where we see, let me explain rapidly. The beryllium here, as the first nucleus, is called father. He will disintegrate. It means he will eject one particle. It is the helium particle. And the rest of the nucleus will be the helium. Another helium is the sun nucleus. Here the confusion, and here the choice of these answers. A, father nucleus is split into smaller ones. B, the obtained sun nucleus is helium. C, an helium nucleus is ejected from the father nucleus, and this is the right example. So when we go to the simulation, here we have to construct the beryllium. So here we can invite some students to come here. This is the beryllium. I need the beryllium 8, and we see that he is alpha decay disintegration. When I click here, we see that the helium is ejected and the beryllium is transformed on helium. So to have the right choice, the right answer, we can choose another massive nucleus, which is alpha decay disintegration, and proceed at this simulation, and the students will see that it doesn't split into half. It doesn't give an helium as sun nucleus, no, but it gives an alpha particle, helium particle. Okay. Second multiple choice concept question, contrasting. So here, the objective is the student will be able to define beta minus decay as nuclear disintegration. And here the problem. Beta minus decay, beta minus, it means one electron. Here, it means that within this disintegration, the nucleus father will give an electron, or already in the nucleus, there is only proton and neutron. So from where these ejected particles are coming? And that's why in the three choices, A, it is impossible that a nucleus eject an electron. For the very rational students that they don't want to find some other choices. A proton is ejected losing its positive charge, wrong answer, but it have certain logic, and the right answer, a neutron is transformed into proton that remains in sun's nucleus and into an ejected electron. Let's see the simulation. So we have to prepare oxygen. Here we build oxygen. What we have 8 exactly, 7, 8, and it has 19 neutrons. So sorry. So I continue here, and 19. We see 19 neutrons, and it becomes beta minus decay. I click, and you see the electron is ejected. But how? And this is a strength of this simulation that we can't find in other manipulation. Here, how the students can give the rational explanation that a neutron will transform in a proton. Look at this neutron here, the gray one. When I click, the color is changed, implying that this neutron is transformed to proton with ejection of electron. And you see, our student will see it for sure. Here, there is all the process explained with those signs. This is neutron, proton, plus the electron with those lines. That means that it is ejected. Third one now, we have to explain the beta plus. Same algorithm, same approach, same answers, but now the multiple choice concept question is ordering. Why it is changing from contrasting to ordering? Because now the students have an idea on the process. So he will order now to find which particle will be transferred. Okay. We pass to the final final individual and small group activity, which is activity. We will use activity sheet. For the activity sheet, that will constitute the core of student workshop, and hence on simulated experiment, students will have some time to play freely with the simulation. They have to suggest experimental protocol, measure variables, analyze data, etc. Let's see this on the final example. The lesson plan of activity sheet is constituted by 3 parts. Pre-lab parts, which is the activity, the qualitative activity, where there is no quantitative measure, precise measure, and gathering data, just descriptive experiments. Then the activity sheet and the pre-lab sheet, this is a beginning for the activity sheet. The activity sheet were the core of the workshop, the core of the activity, where we will discover laws by quantitative way, for example. And then before giving that activity sheet to students, teachers try to reflect, try to see before implementation his lesson plan. Let's see an example. For pre-lab activity, let's see the example of this one of capacitors. And here the objective, the student will be able to identify, to recognize the impact of the plate's surface area and the separation distance on capacitance. So let's see what activity the students can do. So the simulation will present to us a capacitor, what we call plan capacitor. He has 2 plates like this, and here we can isolate the capacitor, and we have the capacitance, its value. And now it is easy for the student to suggest the experimental protocol. It is simple, obvious. Just let vary to these 2 variables. Separation distance, when the plate's separation distance is low, the capacitance is high. So there is an inverse proportionality. Also, for the area, when the area is great, capacitance is great. When the area is weak, capacitance is weak. This is for the pre-lab activity, simple, and can be done by our students. Activity sheet with the strategies described before. Here, let's try rapidly to achieve the objective that the students will be able to discover the formula about the capacitance voltage UC equal Q divided by C. The voltage is equal to charge divided by capacitance. So we go to the here simulation, and before, my students should tell me what to do, what material we need, what we will measure. Describe me the experimental protocol. We discuss it. So they have to figure out that we need to charge our capacitor. We need to measure its charge. When I charge it here, I have the value of its charge here. And I need to measure the voltage on the capacitor. So voltmeter is here. And I measure it. Just 1 minute solar, I'm finished. Okay. And now, point by point, they value the charge, and they measure voltage. They gather them in tables, and they can analyze this data with graphic way, with calculus way, to discover the final formula. Sola, two English word remain in my syllabus. Thank you very much.
Thank you so much, Riadh. Thank you for the amazing and in-depth presentation of, like, you took us through like inception all through the end. And yeah, thank you. There's so much question because of our time. I think we'll just dive in right away. So this is the best time if you have questions at this point, and this is a good time to add them into the question and answer. Use the question and answer feature here in Zoom to drop your questions, and we'll start going over them. And yeah, we can cover as much as we can today. But again, I've seen some questions in the chat. We don't need a WhatsApp group at the moment, which is why we have a group on Facebook. So you can find the link in the chat, and then ensure you join so that we can continue the conversation in there. Like I said at the beginning of the session, there's never enough time to complete this conversation. There's so much to talk about and cover, which is why the group is there to help us continue the conversation out of this group. Thanks again, Riadh, and I'll just dive right into the questions. I'm going to start with something that is slightly different, something you said actually, and I'm reading in Umberia and Dr. Fish's word. Umberia said, "We should celebrate mistakes. This is a powerful statement. Many students are shy of contributing because of the fear of mistakes." And Dr. Fish also went on to quote Richard Feynman, which says, "Mistakes are important." I like what Richard Feynman said: if you don't make mistakes, you are doing it wrong. In your case, what advice do you have for teachers? I'm sure there might be some cultural or challenge with that as well. How do you advise teachers to empower students to retain or take control of their learning and basically explore without the fear of the consequence of making mistakes, which might be punishment? They should see it as an exploration and they learn from that process. But then what advice do you have for educators in engendering or promoting this attitude in their learners or in their students?
Yes. Be patient. Mistakes reveals great data and information about your students. As teacher, I want to enhance the level of assimilation of my students. I can do it when I know precisely what is not going on. And how I know it? When I have patience, I listen, and I don't, even in my faces, I do not express that I am angry. No, just accept that mistakes, especially when there are true mistakes. I mean by that, really the student struggle, and that's why he express himself autonomously. So be patient, listen. This is an opportunity for us as teachers to enhance our students' level by their mistakes.
Great, thank you so much. So please be patient and listen to your students, and we can learn a lot from that process to actually know where to focus or where they need additional help. I'm going through the question and answer again. If you have questions now, there's no better time than now to drop them. Simon and many others are asking that we can take that to the group. If you're going to, if you would share your slide with us later on, if it's okay, or maybe the slide, just let us know and we'll share with the group.
No problem. Yeah, of course.
Have you used PhET-Sim? Okay, yeah. So Dr. Derek Fish is asking, have you used PhET-Sim to reinforce this? Did I get that question right? And how would you include instruments of measurement in future? You know, let's just focus, like, what's your experience in implementing some of these strategies and the examples you gave in the classroom? Have you tried implementing, and what did you learn, or what did you notice in terms of your students' reaction to it?
Yes, we tried, especially the simulation relative to nuclear reactions. We struggle every year as teachers to explain or to extract the explanation of that process, that nuclear process, from students. It is hard, very hard. With simulation, when they notice that color change, when they see that animation, they describe autonomously the process and they explain it without any intervention. Other thing is very, very good to do also. We can act hybridly. I mean by that? We can use PhET simulation with a real hands-on experiment. Simulation will enrich this experience. What you can do with both, do it with hands-on experiments. That's very important. But also you can enrich, you can give the opportunity to your student to manipulate variables that they cannot manipulate with real experiments. So use it both, use the simulation PhET with the theoretical models, mathematics model. It is very powerful.
Awesome, great. Thank you so much. Another question from Annie Zulu. She says, when using all-class strategies, how can a teacher be able to moderate a whole group and ensure that every student gets a chance to speak up, especially when the group is large and when there are also cases when some students need more scaffolding? How can one successfully do that? So the question basically is more, and she says lovely presentation. The question is more, how do you implement all class strategy when you have a significantly large class?
Okay, good question. And I will help myself by the remark of my dear friend Sam. He said, PhET make the invisible visible. This is a good phrase. I saw that on Coursera with PhET teachers, in Colorado University. They have an amphi in hundreds, approximately 100 students, and they are interacting with them, with a group of them, with the whole class. I see in real environment that it can be done. The problem is just to well organize, to have your student sheet, your prediction sheet prepared. When students have something to do, they will engage, and their great number will not make them far from the objective. So you can deal with them, but of course you have to lead. You have to lead. They can't be freely autonomous for large time because of their number, but it can be done.
Okay, great. Thanks again, Riadh. So I'm sure we are closing. We always want to respect everyone's time. So we definitely are going to close on the hour. Unfortunately, we will not be able to get to all of the questions. So I'm advising now that you look into the chat and join the group, which is the community on Facebook, and feel free to write your questions in there. And the speakers, as well as members of the team, as well as PhET fellows as well, will be happy to respond and then continue the conversation there. So we're going to take about 3 more. Hopefully we can get that done in under a minute each. And yeah, we'll see what we have and we'll continue the conversation in the group. There's a question here which says, these are more infrastructure challenges, and I think it's related to the title around using it in situations where there's limited resources. So I have over 100 students in my class, no computers, no projector. How do I use PhET in such a class? And another says, what do you do with a class that has up to 60 students? So different cases in a large class where there's limited technology. What's your recommendation for teachers?
Without at least phones, intelligent phones, we can of course use PhET simulation. But however, we can use the strategy that PhET simulation is using. I mean by that, even from scratch, try to provide contents, experimental contents that you can manipulate when you have a lesson. Just give to your students some simple craft materials that they can with it achieve some simple goals. And to have those ideas, I advise to speak with your colleagues. Speaking with colleagues, taking their opinion is very, very helpful and has a huge impact on the students' performance. But it will be hard. You have to be very, very persistent.
Awesome, thank you. One about, yeah, let's 2 more questions. a question here says, open play session, which you mentioned, like, from my understanding, may result in wasting timed lesson. So what skill can be used to ensure that the lesson objectives are always on time? Because students might get excited and then completely head in a different direction from the objective. Do you have any recommendation for that?
Open play is very important. I am convinced with that. And it doesn't exceed 5-7 minutes. Why it is important? Because the students will build his proficiency to manipulate this simulation. That proficiency, you will need it to achieve quickly your objective. Now, he will, after 7 minutes, when he's free, he do whatever he wants. He will see and know how to vary this variable, how to manipulate this, how to illustrate that. So this is skills that he is building in minutes that you will need it to achieve your goals after that.
Okay, great. Thank you so much. We are time now. Unfortunately, we have to draw the curtain here. It's always exciting when we gather to discuss effective strategies to improve the teaching and learning, especially within our context and some of the unique challenges we might face in our classroom. So you'd notice that many of these challenges are not unique to your space. It's common. And of course, people, in spite of those challenges, find creative ways to overcome them. And then, of course, leverage amazing tools, such as the resources that PhET provide, the simulations, the teacher training resources, as well as the activities that have been created and vetted to be able to improve their classes. So we invite you to explore the website. Please visit the website. Please join the group. I think you'll find valuable resources in there. And also, you can catch up with this recording, share with other people who are not able to join today so that they can also learn from this conversation, and invite them to future editions. We'd like to thank Riadh again for his insightful presentation. Thank you for sharing, and we look forward to hearing from you as well as our future speakers on the session. Thanks again, everyone, for joining. We look forward to seeing you next month in September. Enjoy the rest of your evening, and bye for now.
Thank you, Salah.